All right, so now that we've talked about ionic bonds, I want to talk about the second type of chemical bond that can happen between atoms, specifically between the electrons of those atoms, and that bond is called a covalent bond. It is different from an ionic. Sometimes, between two atoms, electrons are actually shared, which is kind of the exact opposite of the ionic bond, right? Because one atom in the ionic bond was completely stealing or taking the electron from another. But in these covalent bonds, sometimes electrons are shared between atoms instead of being completely transferred. And we can see that happening here between one atom of oxygen and another atom of hydrogen. Okay? Now, this picture is a little incorrect. And what I want to communicate to you is if you can think back all the way to that periodic table I showed you at the beginning of this presentation, every one of those 100 plus atoms has a different liking for electrons. Basically, each atom that exists wants electrons a little more or a little less than another atom. So they're all unique in their attraction for electrons. So the electrons, picture here in black, because oxygen has a different wanting, or we use the word affinity for electrons, than hydrogen, these two electrons would not be so in the middle of these two atoms. Okay? In reality, these two electrons would be much closer to oxygen than hydrogen because oxygen has a very high affinity or liking for electrons. But the electrons would not be completely transferred to oxygen. If we completely transferred these over, then we are going to have an ionic bond. But if we have some type of sharing of the electron, it doesn't have to be equal sharing. It can be unequal sharing, as we're going to find out. Then we have what's called a covalent bond. Basically, you can think of it like I have it written there. A shared pair of electrons between two atoms means that those electrons spend about 50-60% of its time around one atom and about 50 or 40% of its time around another atom. And when I say around the atom, I mean around the nucleus where electrons live, right? So on your screen here, I have three different depictions of a water molecule, right? H2O. H2O. These white balls are hydrogen. The red is oxygen. H2O. Again here, and again here. Okay? Four different depictions of ways to draw the water molecule. The reason we're using this as an example, to transition from the last slide to this one, we showed the sharing of electrons between an oxygen and a hydrogen. That's the same sharing that occurs right here. All right, right here and right here. Right here and right here. Here and here. Here and here. All right. Each hydrogen atom is sharing its electrons with the bigger, more liking of electrons, oxygen. So the shared electrons, okay, are going to spend part of their time traveling around the hydrogen nucleus, which the nucleus, remember, is comprised of protons and neutrons. And the other part of its time, because they're shared electrons between hydrogen and oxygen, the other amount of the time, these electrons can be found traveling around the, you got it, oxygen nucleus. Now, when atoms are joined together by these covalent bonds, this sharing and sometimes unequal sharing of electrons, molecules are formed. Molecules are formed by the sharing or unequal, but still sharing, of electrons. And a molecule is just the smallest unit of a compound, but don't really confuse yourself by trying to compare molecule definition to compound definition. Just know that when two or more atoms come together, you can either call it a compound if it's always in definite proportions, or you can call it a molecule if the two or more atoms come together. Now, why are we going to talk about polar molecules? And what is a polar molecule? Well, I'll tell you this. Polar molecules relate right back to covalent bonds. All right? Right back to covalent bonds. And no, I am not talking about the South Pole or the North Pole when I talk about polar molecules. These are not molecules from the South or North Pole. Instead, these molecules have opposite ends. Like the planet has a north and a south pole, opposite ends. These molecules can have opposite ends. They can have one end that is positive and one end that is negative. This all revolves around the concept of a covalent bond. When covalent bonds are formed between atoms of different elements like oxygen and hydrogen, like I was saying, there are different degrees of attraction for the electron. So in oxygen and hydrogen's case, oxygen is going to take the electrons a little more than hydrogen is. So it's going to be like a 70% of its time around oxygen, 30% of its time around hydrogen. Still shared, it's just an unequal sharing. And that is what I iterate here to you. The unequal sharing of electrons is what creates a polar molecule, a positive end and a negative end to that atom. We'll talk more next time about that, folks.